Welcome back, children. We will move on to the next topic of the chapter, and the next few topics that you are going to learn are law of diminishing returns, then the relation between total product and marginal product, and the relation between average product and marginal product. Now you can relate to the theories that you have learned in consumer equilibrium and demand. There we learned about the relation between total utility and marginal utility. Then you learned about the law of diminishing marginal utilities. Similarly, we will have to learn the law of diminishing returns and the relationship between total product and marginal product. Now let us see what is law of diminishing returns. Law of diminishing returns states that when more and more units of a variable factor, what is an example of the variable factor we have taken? Labor. When more and more units of labor or variable factor is employed with a fixed factor machine, then what will happen to the marginal product? Marginal product of the variable factor will fall. We have learned about diminishing marginal utility. When more and more units of the items are consumed, when more and more units are consumed, marginal utility will fall, isn't it? Likewise, we have to learn in case of production theory also. What is the law of diminishing returns? When more and more units of a variable factor, labor, is employed with the fixed factor machine, what will be the result? Marginal productivity of that labor or variable factor will fall. What do you mean by that? Now I told you, in order to increase the production of shirts from 250 to 1500, that is a target. Increase in the shirt has happened from 250 to 1500. So what should actually that business producer has to do? He has to increase all the variable factors. That is what I have explained to you when I defined the variable factor and the long run, isn't it? Now think of a situation where the number of workers are increased. Okay, now only one particular machine is there and the number of workers are increased with an intention that the more number of shirt production can be met. If that is the intention of a producer, what will happen? You just think of a situation where more number of workers are there and only one or two machines are there. Will any work happen in that firm? If the production of a firm has to be increased, if that increase is in more number, all the factors have to increase simultaneously. Instead of that, here what is happening? Only one variable factor is being increased. When more and more, that is what is given here, when more and more units of a variable factor, what is variable factor? Labor is employed with a fixed factor. So more labors are there with a fixed factor. A fixed factor means one fixed factor. So what is this fixed factor here in the example? Machine. That means if we are employing more labors and if there is only one machine in a firm, what will happen? No work will happen in the firm. Nothing will happen in the firm because these labors will be having the division of work and they need sufficient number of machines to carry their work, isn't it? Instead of that, if more number of labors are being added with an intention that the number of production of the shirts can be increased with one particular machine or a fixed factor, nothing will happen. Instead of that, the marginal productivity of each labor will decline because nothing will work out without sufficient number of machines. Because for increasing the production of shirt to a huge number, division of work, division of work should happen, number of machines has to be increased. Instead of that, what is happening? Producer with an intention that he can increase the production only by increasing the labors, what will happen towards the end? Marginal productivity of the labor will decrease because they don't have anything to do. Only if there is a new machine, only if the number of machines are increased, they can do anything. Otherwise, their energy, their time and the cost is waste. That is what is known as law of diminishing marginal returns. Marginal productivity and its returns are decreasing because more and more variables are added for one particular machine or fixed factor. If that happens, nothing will happen. Instead of that, marginal productivity of the workers will decline. So according to the situation, if it is needed, if the productivity is to be increased to a large extent, along with the fixed factor also has to be increased. Instead of that, only if the variable factors are going on added labors to a particular fixed factor or a machine, the producer's intention will not be met. Instead of that, marginal productivity of the labor will go down because they can effectively use their energy, and the marginal productivity will go a good result, will show a good result only if sufficient number of machines are there. So that is known as the law of diminishing marginal returns. It is a very important theory, and it is important from the examination point of view. Now we will move on to the relationship between total productivity and marginal productivity. Now here you can find, see, the marginal productivity goes on declining from 12 to 10, 10 to 8, 8 to 6, 6 to -4. Why it has come down? Because number of labors are added from 1 to 5, but fixed factor machine is kept constant as 1, 1, 1. That is why it is falling. This is known as diminishing marginal returns. Okay, this is known as diminishing marginal returns, law of diminishing marginal returns. Based on this value which I have given in the table, you have to draw the figure, and you can find that you will be getting a negatively downward sloping curve because of the negative relationship. So draw it and find out the shape of the marginal productivity curve. Now we are going to learn about the relationship between total product and marginal product. You know how you find the marginal productivity, isn't it? MP is equal to delta TP by delta L. Another formula is MPN is equal to TPN minus TPN minus 1. Now with that we can find out the marginal productivity given in the table. Fixed factor as machine or land 1, 1, 1, variable factor as labor 0, 1, 2, 3, 4, 5, 6, then TP as 0, 10, 30, 45, 52, 52 and 8. How do you find this MP? Either by using the formula delta TP by delta L, or by using the formula TPN minus TPN minus 1. For the first one, MP will be blank because 0, the variable factor is 0. It starts from the second step, isn't it? That is what. So you have to find out the difference, isn't it? So delta TP by delta L. By doing that, the values of marginal productivity are as follows. That is 10, 20, 15, 7, 0 and -4. Now you can find, see, in each and every stage you can find 20 plus 10, 30, 15 plus 20, 45, isn't it? The difference between these two divided by delta L will give you the values of MP. You all know that. Okay, we have done example in a simple manner to understand MP. In the table you have to work it out. Now let us learn the relationship between TP and MP. Just as we have learned about the relation between total utility and marginal utility, the same way you have to learn the difference between the relation between TP and MP. Now let us draw the figure based on the table. Now what did you understand from the figure? TP and MP. You can see TP increases initially at an increasing rate, then increases at a slow rate, reaches the maximum, and finally it falls, just like as total utility curve, isn't it? Likewise, marginal productivity curve also you can find it is a downward sloping curve, isn't it? Because it indicates the marginal productivity decreasing when we are increasing the number of variable factors. Now, based on this table, I have drawn the TP and MP. Okay, marginal productivity curve is a downward sloping curve, isn't it? See, it is a downward sloping curve, and it is falling and it becomes negative because when more and more excess of labor is added to the fixed factor, marginal productivity will be falling. Now, you can learn the relationship based on the graph. This is the graph, and I have marked 2 points here, P and M. Now, look at the relationship. The first relationship is, as long as TP increases at an increasing rate, MP also increases till the second unit. So, go back to the table. As long as TP increases at an increasing rate, from 10 it is increased to 30, that means 10 plus 20 is 30. As long as TP increases at an increasing rate, MP also increases from 10 to 20. See? So, till second unit you can find that kind of increase in the total productivity at an increasing rate. There TP also increases, isn't it? That can be depicted in the diagram, isn't it? That is what is depicted in the diagram. You can find, as long as TP increases at an increasing rate till the second unit, it is specifically mentioned, there MP also increases. TP increases from 10 to 30 and MP increases from 10 to 20. Both are increasing. Now, next relationship. When TP increases at a decreasing rate, why TP is increasing at a decreasing rate? What is the reason behind that? Because you know the relationship between TP and MP. TP mainly depends on MP because you know MP is the addition to the total productivity. Now, how will MP behave? In each and every stage, MP will start declining because more and more variable factors are added to the fixed factor. So, when the value of the MP declines, addition to the total utility also will be in that way. Therefore, total productivity will start increasing only at a decreasing rate. You know it very well. You can connect it to the total utility and marginal utility. So, when TP increases at a decreasing rate, MP decreases. That is from third unit. So, go to the table, we can find at third unit, TP here increases at a decreasing rate. Here TP increased from 10 to 30 till second unit, but after the second unit, increase in the TP is only at a decreasing rate. From 30 it has increased only to 45. That means the increasing rate is only 15, isn't it? Now, what happens to marginal productivity there? Marginal productivity starts declining. So, you can see that, isn't it? So, here when TP increases at a decreasing rate, MP starts decreasing. So, once again, when TP increases at a decreasing rate from 30 to 45, difference is only 15, marginal productivity starts falling. Now, next relationship. So here we can see it in the diagram also, isn't it? When TP increases at a decreasing rate from here till here, that is third unit, you can find marginal productivity is decreasing. So what is the second relationship? When TP increases at a decreasing rate, marginal productivity starts falling. Now, next relationship. When TP reaches at its maximum, MP becomes 0. When TP reaches at its maximum, here also you can show the same thing. When TP reaches at its maximum, this is the maximum point, right? When TP reaches the maximum point, MP is 0, just as the relation between total utility and marginal utility. Now, what is the next relationship? When TP starts decreasing, MP becomes negative. You can find, see, in the table you can find when TP reaches at its maximum, MP is 0. When TP starts falling from 52 to 48, marginal productivity becomes -4. See, when TP is maximum, MP is 0. When TP starts falling, MP becomes negative. So what are the basic relationship that we have to learn? As long as or when TP is increasing at an increasing rate, MP increases. When TP is increasing at a decreasing rate, MP will fall. When TP reaches the maximum, MP becomes 0. When TP falls, MP becomes negative. This is due to the law of diminishing marginal returns. Okay. Now we will move on to, so this is what the diagram shows. So learn the diagram and the table properly. Now we will move on to the relation between average product and marginal product, or it can be termed as average productivity and the marginal productivity. Now what is the relationship? Let us see the table. Here the same values I have used. Fixed factors, land or machine you can use. Then variable factors, labor. Then AP is TP by L. The value of TP I have given here, and MP is delta TP by delta L. Okay, so AP is TP by L, total productivity by L, labor. MP is delta TP by delta L. These are the values. Now, how do you get TP by L? You know that, isn't it? TP is 10 divided by 1 is equal to 10, isn't it? Now, 30 is TP. TP divided by 2. 30 by 2 is 15. So, AP is TP by L, and MP you already know it is delta TP by delta L. Now, based on these values, I have drawn the diagram of both AP and MP, and this is what I got when I draw the diagram. That is, values are first MP 1, 10, then 2, 20, 3, 15, 4, 7, then 5, 0 and 6 minus 4. I have depicted it in the form of the diagram, and when I draw the diagram, this is what I have got. Now, on the basis of this, we will explain the relationship. How do we explain the relationship? As long as MP is more than AP, AP rises. As long as MP is more than AP, AP will rise. Why do you make a statement like that? As long as MP is more than AP, AP will rise. Only when the addition increases, average also increases. As simple as that. When addition increases, average also increases. When addition falls, average also falls. That is why we make the statement, when or as long as MP is greater than AP, AP will rise. As long as when MP is greater than AP, AP will rise. Let us see up to the second unit of labor we can see. As long as MP is more than AP, 20 is more than 15, AP is rising, isn't it? AP has come from 10 to 15. So once again I am repeating based on the table. As long as MP is greater than AP, 20 is greater than 15. As a result, what is happening to AP? AP has increased from 10 to 15. So the statement is correct, isn't it? As long as MP is greater than AP, AP will rise. So what should be the next statement? As long as MP is less than AP, AP will fall. That is from the fourth unit of labor. See, from the fourth unit of labor, as long as MP is less than AP, MP 7 is less than 13, isn't it? What happens to AP? AP starts falling from 13 to 10.4. So once again, as long as MP is less than AP, 7 is definitely less than 13, AP starts falling. 13, from 13 it is falling to 10.4. What is the reason? When addition is falling, average also per unit also will fall. Then the next relationship is, when MP is equal to AP, AP is at its maximum, that is third unit of labor. Go to third unit of labor, you can find, isn't it? When MP is equal to AP, 15 is equal to 15, AP is at its maximum. So in second unit also you got to 15, but the third unit of labor is the one which we have to consider. That is the maximum unit of labor, where AP is 15 and MP is 15. So when both are same, when MP is equal to AP at third unit, AP is at its maximum. After that, there is no value of 15 or greater than 15. It is 13, 10.4 and 8. So the third relationship is, when MP is equal to AP, AP is at its maximum. Next relationship is MP becomes negative, AP never becomes negative. MP falls faster than AP, isn't it? You can find it. MP is becoming negative, but AP remains to be constant. Why? Because if MP is becoming negative, again and again the producer will not be intended to do the same process, because already a negative value is experienced. So with that he may either stop. Therefore what happens? Average productivity cannot go to a negative value. So marginal productivity can become negative, AP never becomes negative, and fall of MP will be greater than AP, because MP is addition and average productivity is per unit. Okay, so this is the relationship between AP and MP. Once again we can repeat: as long as MP is greater than AP, AP will rise; as long as MP is less than AP, AP will fall. When MP is equal to AP, AP is at its maximum. MP can become negative, AP can never become negative, and MP falls faster than AP. Okay, so study well. All these topics are important from the examination point of view, and I hope every topics are clear to you. Go through the textbook and learn the tables thoroughly.